This is part of the Simplified revision series. Okay. We have done all the core subjects. We have done like core subjects like biomechanics, medical imaging, bioinstrumentation, biomaterials, even HAP, PYQs that we have done. Okay. We have done aptitude and most of engineering mathematics. And I said there are some statistics things that I will discuss when we discuss measurements. Okay. So there is this measurements and control systems in the syllabus. Okay. We'll do this separately. So measurements and then control systems separately. And in measurements, notice most of the things that you have here, there is a lot of intersection with engineering mathematics. Essentially, most of the things here, random errors, systematic errors in measurement, expression of uncertainty, accuracy, precision, most of this, let's club it with statistics. Okay. And there is a second part where you have all the devices, measurement devices, PMMC, MI, dynamometer, then DC potentiometer, bridges, right? AC bridges and all. So let's do measurements right now. Okay. And in fact, what we are going to do right now is this first part, months one. Okay. And then we'll have to do part two separately. So part two, I'm going to do devices. I'm going to do in part one uncertainty errors and all that. Errors and answer. And here, I'll also do some of the leftover engineering mathematics questions that are there, specifically from statistics. Okay. So specifically what we are doing is like 4 years of PYQs starting from 2020 to 2023. And today we'll look at statistics and measurements. Statistics from engineering mathematics and measurements. Okay. Measurements right now we'll do errors, uncertainty quantification, all of that. Even units, dimensions and all of that. Okay. Give you bare minimal theory. Roughly the concepts over here, there is units and dimensional analysis and basic mean, median, mode, basic statistics. Okay. Representing accuracy, precision, uncertainty, errors and all that. And then when you're working with group data, how do you deal with things? Okay. So roughly mostly this is a statistics part. And we have all the measurement devices over here. Okay. Let's get started with this thing right over here. Okay. Units and dimensional analysis. And so the first question is MLT correspond to dimensions representing mass, length and time respectively. What is the dimension of curve? Notice. So before I start this, let me tell you two things. Okay. One is this extremely useful, not just to answer questions from this topic, but to answer questions from any topic, right? For example, for NET questions that you don't know, right? Often good rule of thumb answer can be obtained using units and dimensional analysis. Okay. Given you two numbers in the question, 13 units. If you multiply the two numbers, you get the answer units. The Wien's displacement question, is something that I showed right in bioinstrumentation, in temperature measurement. Two numbers, if you multiply the two numbers, their units correspond to, the multiplied units corresponds to answer units, right? That makes a very, very good rule of thumb answer for NET questions that you don't know. And you know how to do units and dimensional analysis. You can also do elimination verification for many, many questions. Many incorrect equations can be easily identified. Okay. Correctness of at least LHS dimension should be correct equal to RHS dimensions. That can also be quickly verified, not just in measurement questions, but let's say in math equations, bioinstrumentation, any subject. Okay, you can quickly do elimination. In fact, the preferred order is first eliminate and then verify. So you can quickly do elimination verification. And again, get some edge on questions that you don't certainly know the answer for. Eliminate and verify. For that one reason, there's a very, very, very cool tool. And I'll show you two quick examples on this right away. So the NET questions rule of thumb I have already shown you, right? The Wien's displacement question. Elimination verification, I'll quickly show you some examples. Let's go to the first question. ML and T correspond to dimensions representing mass, length and time respectively. What is the dimension of viscosity? Okay, now can we get some answers on how you would go about answering this? You have viscosity and a bare minimal, you are expected to know this. Okay, at a bare minimal, viscosity plus or not T. So A quick way to answer this, okay? First is to recognize a viscosity. If you can recall that, viscosity is typically expressed in Pascal second. Let's say you recall this. If you recall this, then the answer gets kind of easy. Okay, you have Pascal second. Pascal notice is force per unit area, right? So you have unit of force that you need to know. Okay, so let's write this. Skull happens to be a force. So this is mass times acceleration. You have kilogram meter per second square. This force still is force per unit area. So you need to also have this into 1 by meter square. This is a Pascal, right? Then you have this second over here. So what I have written here essentially is on this force term, you have force per unit area, Pascal into second. At this stage, you can quickly answer what the question is. Okay, this second and this second, it gets cancelled. This meter gets cancelled. You have mass by second inverse or mass by second by meter. That is mass second inverse time inverse. Okay, at this stage, you can go answer. This is m L minus 1 T minus 1. That is mass power 1, length power minus 1, time power minus 1. If you can recall, this is Pascal second, you can answer at this stage. So someone had a question. So when should you use, when is this 75% of 75 kgs? When should you use that? And when should you use, 75 into acceleration due to gravity? All right. In fact, let me quickly answer that question and get back to this question in a moment. Two things, okay? Mass, okay, this is in kgs. Okay, unit for this is in kg. Example would be, let's say, 75. Then you have weight, okay? The symbol typically used for this is m. Notice weight would be mg. Depends on the acceleration due to gravity. Notice mg, this is mass times acceleration due to gravity. Typically at a place where, place in earth, this is 9.8 meter per second square. Okay. So this is 75 kilogram, okay, into 9.8 meter per second square. It's acceleration. Double derivative of distance with respect to time. Take distance, two derivatives, right? Mass by second square. Sorry, meter by second square, right? This is weight. Okay. This number can be quickly calculate what this number is. Yeah. I don't have a I don't have a calculator. Yeah, I do have a gate calculator here. So 75 into 9.8 135. Okay. This corresponds to 735 case 135. Okay. Kilogram per second square. This also happens to be, this is the definition of 1 Newton. Okay. This also corresponds to 735 Newton is 1 kilogram meter per second square. So you have Newton. All the terms over here, okay, is our force. Forces. Doing force equilibrium statistics, you are supposed to use mg, that is a unit in Newton. You are not supposed to use 75 kg, say, for force equilibrium calculations. For all statistics problems, for elbow, knee, thigh, and all that, weight of the body, weight of the foot, weight of the object, each of the things, you are going to use this because weight is a force, okay, and has units, SI units of Newton, which is essentially kilogram meter per second square. You can also write down the dimensions. This is m, mass, length, t power minus 2. Okay, then now if we go here, so notice I took that force per unit area. So I divided by 1 more meter square to get the unit of pressure. Okay, multiplied by second, and that resulted at this unit. Okay, so question number 1, when should I use mg and when should I use m? For all force calculations, use this. You'll be using this in, let's say, in moment of inertia calculations, right? mr square, let's say. It's not mgr square, it's mr square. Okay, it's mass into, square of a distance, right? In moment of inertia calculations, for example, mass shows up. In all force equilibrium calculations, statics, problems, right? Joint analysis and all this. The force, weight is a force, that shows up. Distinction clear. And notice, so with this, I essentially put a Newton by meter square, that is pressure into second. I got this answer. Okay. Just in case you don't know this, that is, you couldn't recall this is Pascal second. What I would do was I would refer back to the original equation, that is, or definition of viscosity, which is tau is mu times dot. But you are slightly dredging into dangerous waters because now you are expected to know units of couple of other things. Okay. For example, notice this is in units of, this is at least what kind of a quantity. This is a pressure like quantity. Okay. Or, this is like a stress. Okay. Stress is a pressure like quantity. So you got your Pascal from there. Okay. This is strain rate. Strain has no dimensions. The rate has 1 over T, right? This is units of second inverse. Dimensions of LHS and RHS should be the same. That means this should have units of stress into second. So that LHS you have units of dimensions of stress, RHS you have dimensions of stress. The second and second inverse will get cancelled. You can also kind of infer, notice I got that Pascal inverse over here, stresses in Pascals. Okay, force per unit area. I kind of, even if I couldn't recall this, I kind of could get it from the definition. But as I said, here you are expected to do a little more recalling that, hey, what is stress, what is strain rate and all that. And this is something that most of the marks again are lost on units. Okay, so stick to SI one. Well, that is one thing that I have been stressing again and again. Another thing is, it's a good idea to know, be aware of the common SI units on dimensions of the general parameters that show up in PYQs. Okay, so that will also help you with elimination and verification. Sometimes to even answer guess answers to NIT questions. Okay, fine. Let's look at this question. We have already seen this. So blood flow through arteries, propagation of speed is this, pulse wave propagation speed. This is Boyan's quirky work, right? We have seen this in bioinstrumentation. Once you can get the wave speed using some things, right? We have this mnemonic. What is our mnemonic? This is square root of ET by rho d, right? So this is T rho d. D is the diameter. Make sure things are all matching. Okay, C is the wave speed, E is the Young's modulus, then T is the wall thickness, D is the diameter of the artery, rho is suppose fluid density. Yeah, fine. That is correct. I'm saying that this is ET by rho d. So at this stage, you can recall this is not rho d by ET. You could recall it's not E rho by dt and all that. At this stage, you can recall. Let's say not examination day, you forgot the mnemonic and all that. You could always do dimensional analysis. Again, I'm going to first eliminate and then verify because I can save some time. I know it's not E rho by dt for sure. I also know this is not rho t cube by E for sure. I just forget it's ET by rho d or rho d by ET. Let's say that confusion kind of arises. Okay. Then quickly verify. So you have sigma is E epsilon. Epsilon is strain as unitless, dimensionless. So this is change in length, normalized change in length, right? So E has units of stress or Newton per meter square. Okay. So if you take this option, see, let's check the units of the RHS. I have Newton per meter square for E. Okay. For T, this is meter. Okay. Or D, this is meter. And then for rho, this is kilogram per meter cube. I got kilogram per meter cube. Let's see if we get units of, if this is at least dimensionally correct, we should get wave speed, the distance by time units, right? So this gets cancelled, this gets cancelled. You got, this corresponds to square root of Newton, that just said this is mass times acceleration, kilogram meter per second square into meter kg. The units of this square by second square root of that. What do you get? What is square root of meter square by second square? Meter by second. Units of speed. I know this. This has units of, notice, second by meter. LHS has, you just did that calculation. No? This is second by meter. It cannot be. And actually use this to verify, in fact, to eliminate many MCQ, MSQ options in the whole paper. Any equation has to be dimensionally correct. It's a very powerful elimination verification technique. In this case, even if you don't know what this bonds quotivac is, right? Let's say we don't know what that is, and still actually go ahead and answer this question based on just, dimensions. And it's very powerful. So do things in SI, be familiar with common, dimensions of common terms that we use. What is pressure, what is force, what is mass, and all that. I hope there is any misconception here, doubt here got clarified with should you use m times g or m times, just m, right? I hope that got clarified. Finally, the dimensions is a powerful elimination verification technique. Fine, let's move on. This is the magnitude or the difference between the mean and median of the data set. Quickly, let's just write it over here. In the definition, summation of all the numbers by n. It can be weighted, but I didn't do the weighted thing right now. Okay. Median, this is center value. Mode, this is most frequent value. So notice there is no mode here. None of the things repeat. All data points are equally likely in a given set. Okay. If there is a 2 repeating, if there is a 8 repeating, the mode would be 8. Okay. Right now it's not repeating. This is the most frequent value. Really, bimodal distributions and all that, mean can be very deceiving. So you go by the mode. Again, there are uses for median. In this case, so based on the definition, what is the sum of all these numbers by n? So the n is six numbers in this data. So your mean, the summation of all this, I suppose, is 8, 14, 18, 21, 24 by 6. That is 4. A median, there are odd number of terms. This is a center value. Right now we have even number of terms. So this is average of the two center values. Okay. Median, because there are 6 terms. This is even, right? Even terms here. This is average of the two center terms. There is no one middle value. And happens to be 3 plus 4 by 2. That is 3.5. The difference between them is 0.5. I quickly said, okay, so, bimodal distributions, things with multiple modes and all that, complicated data sets, mean can be deceiving. That case, you use more. Okay. And then median, the center value. Okay. In fact, when these are useful, specifically, they can cook up theory questions based on that. Let's go to this question. Shown in the circuit below, a constant voltage source is connected to ideal resistors. Voltage drop across the resistor is this. Expected voltage drop at this stage, I'm just going to write that down. What they are supposed to measure is phi by voltage division rule. Let's assume this voltage sources are all, the voltage meters are all ideal. Okay. So what it's supposed to measure is 2.5 volts. Phi divided between this 100 and this 100. Okay. What they are supposed to measure here, let's say if this is grounded, you're supposed to measure 2.5 volts. That comes from voltage division. But what they are measuring is some numbers in and around that. Question is, which is accurate, which is precise. So quickly, what is accuracy, what is precision? We describe this in simple English, accuracy, precision. Very simple English. Close to actual value, close to actual or true value, fine. So accuracy is loyalty to truth. Precision is loyalty to the group, loyalty to your friends, close to each other. Doesn't matter what the truth is, right? Circle rules, right? Friend circle ethics, right? Close to each other. A proxy for this is different from actual mean. A true value, actual value, in a mean, sample mean. This is a proxy for this. What is a proxy for this? This will be mean of, a proxy for this would be like, technically standard deviation. There are many things. Standard deviation. I'm not going to define all of this, okay? Most of you know the formulas for this. Standard deviation varies or variance. In simple English, RMS of root mean square, error or values, RMS of differences from sample mean. The definition of variance and all that is by default that, okay? Standard deviation is that. Root mean square differences can be positive, negatives. I'm using root mean squared value, okay? The RMS of differences sample mean. Actual value doesn't matter at all from sample mean. Okay, can we stare at this and at this stage answer? Right line, this is a spread of about 0. This is data spread in and around 2.5, the true values. The mean is getting closer to 2.5. This is all less than 2.5. Notice the second row is strictly less than 2.5. The mean of that would be around 2.47. Okay, slightly higher and lower, around 2.47. So I can quickly say V1 is more accurate. V1 is more accurate. I can quickly say that. If you want to be safe, you can do the calculation. What is the mean of this? What is the mean of this? How do they compare with 2.5, right? About the variations here, the maximum, this is 2.511, 0.011 on this side, and this is 0.021 on this side. Variations here, 0.04, 0.035 on this side. It's all actually, these are very close to each other. Okay. The mean of this, let's say roughly 2.47. Differences are actually 0.005. Here the differences here are of the order of 0.01, right? 2.5 plus 0.01 would be 2.511. 2.5 minus 0.01 will be 2.4948 and all that, right? And quickly see, this is more precise, okay? Comparing these two numbers, again, I have to write the mean here. For the first set, the mean is roughly 2.5. 2 is more precise. They are all close to each other. You can again stare at that and say, if you want to be really safe, you can actually find the standard deviation on that, okay? But this is actual value minus sample mean. That kind of quantifies accuracy. You have to find the sample mean, find the differences from sample mean, then take RMS values of that, okay? If you want to calculate it. That is, you have to find mu bar, mean, this xi minus mu bar is the differences, okay? You have to square them, find the mean, okay? Here n is pi, summation, and then you have to do a square root of that. If you want to do that, you can do, okay? This question is answerable. You can share the numbers and answer. So I'm not going to do that over here. And notice, be aware there are 4 possibilities. Let's get nice circles. Let's say the true value that we are measuring here at the center, the bullseye, measure of precision, or independent, okay? Things can be accurate and precise. The data points are kind of in and around this. Things can be on an average accurate, but not necessarily precise. The average is around the frame. Things can be precise, but not accurate. All the data points are somewhere over here. Things need not be accurate. Things need not be precise. So this is accurate, precise. Okay. This is precise, accurate. This is neither A nor B. Okay. Let's go to the next one. Independent voltage measurements for 3 sensors. Measurement uncertainty in V1, V2, V3. There is one important statistics result we'll be using here. Can anyone recall what that is? Mu and standard deviation are given. The uncertainty for the summation of 3 values. Measurement uncertainty of the sum. Again, there is something called central limit theorem, right? Let's say V1 follows given no other information, sigma 1. Right, let's not confuse with this given u1. Let's make it any variable. Height follows a normal distribution. It has a mean and a variance. You can write it, what I have written as a standard deviation. You can also write a variance. I prefer writing the variance here. What I have written as, let's say some variable follows the normal distribution. That is what I have written. Okay. This tilde is follows, and this is normal distribution, Gaussian distribution. Let's take one more variable, x2. Let's say that also follows, not very surprisingly, let's say normal distribution. Has a different mean. It has a different variance. I'm writing variances here, not standard deviation. Let's say this is length of hand, okay? One is height, one is length of hand. This is different variables. Now if I like stretch, what would be my total height, right? Stand and stretch. x1 plus x2. More of these 2 variables. One is my height, from toe to the top of head. One is length of my arm. So if I stretch it like this, that's a total height, right? What does this follow? This again follows normal distribution. This is a property of normal distribution. But what would be this mean and what would be the variance here? Can anyone fill this gaps? If you add 2 numbers, 2 variables, what should happen to that means? This is fairly easy to guess. The means get added up. One is 6 feet, another one is 1 feet. Let's say Both of them get added up, right? Summation will be like 7 feet on an average. How about this? What would be the variance of the summation? Can anyone fill that up? You have seen this in class, and there's a very, very important detail. And almost every year, one question shows up based on this. Even the question that we are looking at right now is actually, it depends on this. One way is and 0.02. No, again, that's where you have to be careful. You have to be very clear. You cannot just add. That is one way, because what is given is standard deviation. There are many, many errors of measures of error. What is given is standard deviation. All things add up. Hey, we have seen this in class. I have posted questions. There are being PYQs based on this. We have discussed in a GATE 2024 paper, even we discussed, right? No one can fill this one up. Very simple. The variances add up. The means add up. The variances also add up. Standard deviations don't add up. That's why I wrote it this way. The variances add up. And all of you know that standard deviation is square root of sigma, right? This sigma. This is square root of variance. That is sigma square. So the variances add up. The answer here, because of that, would be the variance of first one. Okay. In the first one, 0.02 square. In the deviation is 0.02. Variance is 0.02 square. In the second one, 0.2 square. There's 0.02 square. There's 0.2 square. In the third one, 0.15 square. This is the combined variance. Because of this, result in normal distribution. And the deviation of that would be square root, which is that. But tell me the answer for that. And also tell me if you have any doubts on this. And this is very, 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 very important. If x1 follows a normal, x2 follows a normal, the summation of x1 and x2 again is a normal distribution. The means being the summation of the means, the variance being the summation of the variances. You can extend that to more than 2. You can quickly, if this is the case, you can quickly show that, right? You can take 2 variables at a time and show that. How much is that? Yeah, I just, did that in the GATE calculator. You get 0.05, 0.25. For example, if you had to add the standard deviations, the result you will be getting as 0.37. You did sigma 1 plus sigma 2 plus sigma 3. You would be getting 0.37. No, you have to add standard deviations. Can add variances. This is important. So let me write that again. If x1 follows normal, x2 follows normal, summation also is normal. This also for normal, also follows normal. The means add up here, and both means and variances add up. Means and variances add up. Yeah, you need to know one more thing about Gaussian. Okay, the area under the curve. So Gaussian curve, the tail. So let's say this Gaussian curve, that is most of the data is centered around the mean. Okay, one standard deviation, this will be roughly sigma. This area under the curve here, technically this is symmetric. Okay, so this is the area under the curve here. Mu plus sigma and mu minus sigma. How much is this area? Does anyone recall? This is 68%. With 2 sigma plus 2 sigma, mu minus 2 sigma. Area under that would be 95.5%. 3 sigma will be roughly 99%. Okay, 9999. These two numbers are very, very helpful to remember. For the Gaussian curve, probability within a data point within one standard deviation, that is on either side, is 68%. Two standard deviation is 95.5%. In a measurement process, groups A and B recorded 10 and 15 values respectively. Arithmetic means and standard deviations of groups A or is 65%. I don't know where you are getting this from. 65% you can write it, or you're going to end up outside of the key range. Okay, the numbers that I have given, or you're going to be in the key range. It's around 65, 68, 95.5. Even sometimes, even if you use 95 or 96, you can go out of key range. That's why I gave that number correctly. 95.5. And then, more than 99.5, that is 3 sigma is fine. Be careful. The measurement process, groups A and B recorded 10 and 15 values respectively. Arithmetic means and standard deviations of groups A, B, or thus. You did 2 separate measurements. Or, there are 2 groups in class, group A, group B. Group A did the experiment, they got a mean and standard deviation. Group B did the experiment, they got a mean and standard deviation. The standard deviation for the combined set of group A and B data. If you now combine the 2 experiments, what should be the mean and standard deviation? Let's again write this down. You have mu A sigma A from group B. Okay. And then you have a mean of P, sigma of P from group B. And there are n number of data points here as NA, number of data points here as NB. Your means is fairly easy to write. Combined group mean, mu AB, is just weighted average of the two means. This is just mu A, mu B, by NA plus NB. But it's weighted average, so you get a weightage of, NB data points here, you give a weight of that here. NA data points here, you give a weight there. That's just weighted average. Then comes what is group standard deviation. For to use some space here, right? Sigma AB happens to be square root of roughly sigma A square, weighted average of the two things. Okay. Sigma A square plus sigma B square. Again, you have to do a weighted average. So this is NA plus NB. And this is NA weight here, NB weight here. But you also have to account for few more terms. So that will be DA and will be DB here. Your DA and DB will be, DA is how much mean of A differs from group mean, mu AB, deviation of the mean. DB again, how much does the group mean? Sorry, the B groups mean different from the combined. Let's quickly do some calculations over here. Notice I wrote it in a format where, this is just simple weighted average, right? Can we quickly calculate what these numbers are? So you have your NA here, your NB here. The N is a number of recordings. That's why I also kind of wrote it down here. Yes, the number of recordings, N and 5 values. If someone has more number of data, you give them more weightage. So what we want is the standard deviation, but to find that, we also need to find the mu AB and all that. The find mu AB, I'll tell you what DAB and all that is. Can you find what this is? Others could do the weight mu A. Okay, mu A is 35. 35 into 8 into 15. Then divided by 5. 10 plus 15, that is 25. 36.8. This number is 36.8. Your DA and DB are deviations from this mean. Combined mean, deviations from individual means. So for example, your DA is 36.8 minus that group's mean, which is 35. Okay. And for clarity, let me write it down at the top. Your DA is group mean, say the combined mean, minus 35. Can we also get this number? I suppose this is 1.8. Okay. And then your DB, this is the combined mean, 36.8 minus that group's mean, that is 38. Okay. This is 1.2, I suppose. Minus 1.2 doesn't matter. You're going to square it up. Okay. Now let's go find this term. Yeah, see, notice this is quickly dimensionally not correct. DA has units of standard deviation, right? So you cannot add that with variance. It has to be DA square and then DB square. Take the variance of A, add that with again the variances add up, but you need to account for the deviations from the combined mean. Okay. These numbers we already calculated. Let's just do this calculation once. It's going to take time. Okay. So this is 1.8, this minus 1.2. You know the rest of the numbers. Okay, anyways, you are going to square it, so the symbol doesn't matter. So rest of the numbers, NA is 10, NB is 15. Sigma A is 0.4. Sigma A square would be 0.4 square. Sigma B would be 0.6 square. And we quickly find that one now. So what we need is finally the answer. Sigma AB. Confused on this, let me quickly, say the variance is just weighted average of variances. Just like weighted average of mean, weighted average of variances. But yeah, there are some correction factors. Okay. Variance is just weighted average or the individual variances. But you have to account for this deviation of group means from combined mean. So there are some correction factors. You have DA square plus DB square. Very easy to write that down. Need is a standard deviation. So take a square root of this. It's kind of, this formula is easy to remember. Okay. Can you all calculate what this is? This 821.49. And qualitatively notice the means are actually far apart. They are farther than, in fact, 3 standard deviations. So there is actually a lot of discrepancy between groups A and B. And if you don't consider this deviations from combined mean, that is discrepancy within groups, your any guesstimate of your variance is going to be, uncertainty is going to be off. In simple terms, the group data is like highly discrepant. When you combine it, uncertainty should be very high, higher than what is there in the individual groups, 0.4 and 0.6, okay, or in the squares of that, because there is a discrepancy among groups. I just said this, right? So this is even 3 standard deviation is 99.7, I think, okay. The things are, this is 35 plus 3 sigma would be 35 plus 1.2, right? 36.2. The mean is farther away from that, highly discrepant. So standard deviation for the combined set, which is a measure of uncertainty, should be very high compared to uncertainties of the individual things. Yeah, that happens to be 0.56. So the groups are very different. They combine them, the uncertainty is like too high, which is why, this standard deviation 0.4, this standard deviation 0.6, but you're getting a very high number here. And you wouldn't get that correct uncertainty if you don't account for this discrepancy in the between the groups. That is, how much does the group mean differ from the combined mean? That discrepancy needs to be accounted for. Okay, and that is a quick justification for the form of this. Notice, imagine if this DA were not there, you're going to get some numbers, close to 0.5 and 0.6. You'll be getting 0.55 or something like that. 0.55, 0.56. Okay. Yeah, be careful about it. So this is much higher than 3 sigma for that group. And this is actually 2 sigma for that group. The probability of that happening is highly unlikely, but it's happening. So uncertainty is very high in this case. Okay, now let's go to the last question that I will discuss now. Okay, this line fit problem. Gynecologist recorded blood pressure using regression, the diastolic blood pressure for a 38-year-old patient. What it says is, if you plot age versus blood pressure, most lie in a straight line that you can fit things. Age, you have BP. Let's put a kink here. Age starts from, let's say, 20 to 40. 20, 40, T. Blood pressure ranges from, diastolic BP ranges from 60 to 90. 60, 70, 80, 90. The reason I am doing this is, you can quickly get a reasonably estimate based on this if you forget the formula for some reason. Okay. So let's plot all the data points. That's not a data point that I plotted. That's just a grid point that I plotted, reference. Okay. Yes. So 23, 65 is over there. Let's plot them. 23, 65, this point is over here. 24, 60. 24 happens to be this point. Okay. And then you have 25, 62. Okay. So 25, this point is over here. 26 is at 70. 26 is at 70. 28 is at 70. And then 29 is at 73. And then 31 is at 75. And then 35 is at 83. 40 is at 90. You want us for 38, how much is this? How much is this value? Roughly, you can see this is around 86, 87. Okay. Compare it with the answer key here. So key happens to be 86.5 to 87.7. Can get close, but this is not a safe way of doing this. Yeah. Which is where you have to actually do a regression, and you have two variables. You have to fit a straight line. You have to fit a y is equal to mx plus b. Let's say ax plus b. You have to fit a straight line, and this formula is much easier to remember. So I'm going to prescribe that. If you write this as a minus y bar equals k into x minus x bar. X bar is mean of x, y bar is mean of y. Fairly easy. This k is sometimes referred to as the regression coefficient. Notice this is the slope of that line. Y minus y1 minus y2 by x2 minus x1, right? It's the slope of that line. K can be easily found out. Okay. This xy, I'm just writing a mnemonic. Xx. Okay. This is sum of products minus 1 by this is product of sum. We once again. This sum of product. This is product of sum. Okay. And this is also sum of product minus 1 by n, product of sum. Okay. I haven't written the formula. I have just written the mnemonic. The formula would be this. Okay. This is a summation of products. The product of xi, yi, summation of that minus 1 by n. Okay. Product of summation. You have summation 1, summation 2, the product of that. Yeah. So in the numerator, it is x and y. The denominator is x and x. So this is summation of xi, that is just xi square minus 1 by n. This will be xi summation of xi. That is just nothing but summation square. I have written here is only the mnemonic. Okay, this is actually the reason to prescribe. There are many forms here. Sometimes they prescribe, hey, what is this A and what is this B? But often in a gate exam, this is much easier to calculate. So I'm telling you this. Okay, xi is already given. E is given. You can find the product. Easily find the summation. You can easily find the summation. You can find the summation. You can square it. You can square it and find the summation. There aren't any differences or anything like that. Okay, differences from the mean. This is much easier to do. And the mnemonic that I use is it's xy in the numerator, xx in the denominator. And this is always summation of a product of x and y minus 1 by n into product of summation. Summation of xi into summation of yi. Same thing in the denominator also. This is summation of a product, but product between xi and xi. So this is xi square. It's product of summations. Summation xi product with summation xi. So this is a square. This is much easier to calculate. Often you can save about 2-3 minutes if you were to use this version. And then the question arises. So once you have fit it, you can always find it for a new data point. But if you want it in this format, okay, the y bar would be noticed. In this version, okay, this happens to be equals to, corresponds to, okay, y equals x plus y bar minus kx bar. There you got your A and B. This is, these two equations are one and the same. Okay, they are equivalent. B here is just y bar minus kx bar here. A here is just a k here. K goes by the name regression coefficient. For example, in this question, biological study, they have experimental values measured from 6 subjects are given below using the data linear regression coefficient for estimating the weight of the heart based on systolic pressure. Systolic pressure and weight of the heart are kind of correlated. What is a linear regression coefficient? What they are asking for is the K that I just wrote down. Let me quickly write it down. So you have, let's say, xi, yi doesn't matter. Okay, this is yi. You are estimating this using the weight of the heart or using the systolic pressure. Let me write this down again. This is summation of product xi, yi minus 1 by n product of summation xi, yi. Okay, divided by the same thing. So this is summation of product xi square. Okay, and then product of summation. So this is product of this into this. So this is xi square. Get some numbers quickly. This happens to be, what is the summation of xi here? What is the summation of yi here? Sigma xi and then sigma yi. How much is this? You need one more thing in the table, which is just xi square. In the other way around, you have to fill up 2 more columns in the table. You need a table with 5 columns. Here you just need a table with 3 columns. Okay, 2 are already there. You just need to fill up this thing. So this is 120 square 400. Okay, and then I have 90 square. Write it this way: 4400 100 100 square 1000 110 square into 100 140 square 9600 130 square 30 square 6900. Yeah, can you tell me the summations of this and also the summation of the last bit over here? This is the summation of sigma xi square. Sigma xi. Hey, someone also, quickly double check this. I'm just writing the numbers that I'm getting in the chat. Okay, 690. Let's do this. 20 plus 90 plus 100 plus 110 plus 140 plus 130. 130. Okay, 690. What is this summation? Summation of xi square. Okay, you found the square. I'm going to write that down 1100 sigma y 800. I'm doing this in a gate calculator. Okay, 100 plus 420 plus 90 plus 490 450 550. Notice I just needed one additional column. There is one more formula for regression. That would need two more columns that will have xi minus x bar, ya minus y bar, product of xi minus y bar into that. That will run into, you need all of this. Okay, xi minus x bar. You will have this column. You'll have ya minus y bar. Then you will have this product xi minus x bar into y minus y bar. This product and all will show up. You'll have to do three new columns and add all of them together. In what I have done, you just need to do one additional column. Okay, you got all these numbers, plug it on here. N happens to be 6, Can you find out how much is this? You actually still need to do XIYA. Okay, fine. You need two columns here. Still, two new columns instead of three columns. XIYA 20 into 500 got 60,000. 90 into 300. 20 into 300 is 7,000. 100 into 420. 4200. 42,000. 110 into 390. So at this stage, if you ask me, sir, can you just, we are spending more than, looks like we are spending more than 8 minutes with practice. So students in the past, they could do this with under 6 minutes with practice. On the K formula that I am showing. Okay, they could do it. But if it's say, let's say, taking more time, what doing in the exam, right? That is why this I made a reasonable guess. Happened to be wrong for this question, but you can get good answers. Otherwise, the simplest thing that I would do here is, see, these two data points are, there are some problematic data points here. These are problematic, errors are too high. But these data points are reasonably good. Okay, so I'm going to pick two of them. Let me pick one data point. Okay, let me pick what I will be doing here as y minus y1, x minus x1. This is the slope. This is a sensible data point, and the y that I want is an unknown. I can quickly tell you how to regression coefficient from this. Okay, let's say y2 minus x1. So this data point was good. In fact, even this data point was good. The errors are all, these are all error data points. There is a lot of spread there. So let me use these two data points and show you how to find the regression coefficient quickly. Okay, so m is approximately, here I have my x and I have my y. Okay, 83 minus 75 by 35 minus 31. Okay, that happens to be 83 minus 75, okay, divided by 55 minus 31, that is 4. It's roughly 2. There's approximately 2. And once you know that, if you know, you got the mx, right? You got a. Still need to find the p. Actually, let me show you how to find that p over here, okay? Already said you got your the regression coefficient k, m or k, doesn't matter, okay? You need to find x bar, y bar. Your x bar is average of all this. That's fairly easy to find, okay? Let me do it. 23 plus 24, 25 plus 6 plus 28 plus 29, 31 plus 85, 40. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. Did something incorrectly. I'm shuffling between, two PYQs. The reason is, okay, because I'm not just trying to solve what is being asked. I'm trying to show you what they can possibly ask, right? And the other question, they can technically ask you similar thing. Given for some other new x, what is the value of y? Or a new y, what is the value of x, right? As in this question. This is one thing. And also, once they tell you how to find the k, the slope m, right? I also need to tell you how to find a and b, right? So that's why I'm doing this. 29 plus 1 plus 5 plus 40. In somewhere over here is 29. And the y bar here is 65, 60 plus 62 plus 70 plus 70, 73 plus 75 plus 83, 90 divided by 9. This is 72. So now your K is 2. Okay. That is your A. And your B happens to be bar minus KX. 72 minus 2 into 29. Okay. That happens to be 58, 22 minus 58, 14. So now you know your A, B. Then you can quickly find out for a new X, that is for a new 38, you can quickly find out what this value is. Actually, yeah, notice actually when I did it, got a 90. So even at this stage, if you find approximately find K, notice necessarily working out. Approximations don't work out. So in fact, my suggestion is if this shows up, just skip it. Okay, 2 more questions, just skip it. The formula is this. There have been students who could do this in under 6 minutes, but let's say 8 minutes. But, it is taking a lot of time, skip it. Okay, in this case, let's say what is the actual K that we got it. Let's also check this. What's the number that we are getting based on this? Yeah, I had to find that XI, YA. Forget that. So this is 490 40 into 490, say 600. 30 into 450. Okay, then what is summation of XIYA? 60,000 plus 7,000 plus 82,000 plus 82,900 plus 68,000 plus 58,900. I am getting 299,000. This is primarily testing your ability to click mouse clicks. Okay. So if some of these numbers are slightly off, it is testing very different things using a get calculator. So, okay, if I use this, what is the value of K that I am getting? Can I just calculate that? I have all the terms. I have this summation, 2,99,000. I have this summation, 690. I have this summation, 2550. I also know N. So I know all these terms. I know the summation of these squares, 81,100. Again, all the 690 square, I can easily do this, right? If we do all of that, what is the value of K that we are getting? Let me also do that. 5750. I am getting 0.8. Happens to be 3.8. Does anyone have the answer key for this? Okay, so notice got in the 2.3.27 to 3.31. In the unlikely event, okay, we hit upon this 3 sigma, 6 sigma situation where we got the actual answer, which is unlikely to happen in the actual examination. The key range is 0.27 to 3.31. Okay, so this is how you find the K. Once you find K, can find A. You can find B by it's just Y bar minus KX bar. You know the mean, so you can find the B. Okay. So why it's in the Y is equal to AX plus B form or MX plus B form. And then for a new value of X, you can find the value of Y as you did here. But is it worth doing on this step? At least, this question doesn't make sense. Okay. I would just do what I did initially to roughly plot it and guess the value. I guessed 86 and I will move on. If they ask me for K, I just need 2 more new columns. There is no Xi minus X bar, Yi minus Y bar or product of Xi minus X bar, right? I have to find, 3 new columns and also that's a difference, slightly harder to find, okay? Using this formula, you can just 2 new columns, you can easily find out. If they are asking for the regression coefficient K, perhaps I would do it. It wouldn't take more than 8 minutes for sure. I would do it till this. But in this question, let's say they ask you for a new weight, for a new or systolic pressure of, let's say, 145, or it's extrapolating, right? For a new systolic pressure of, let's say, 135, what would be the weight of the heart? That is something that I would consider skipping, or, just make a guesstimate and move on. Okay. It's just a waste of time. And, this is just testing your ability to click the mouse, right? So I would say this is worth skipping. 2 marks is worth skipping. At least I make a reasonable guess and move on. And also all this number crunching, the gate calculator is very, very tiring. You have to look at, fill up this. So this is very tiring. This is prone to error. So many numbers. If you are not, plus you like numbers, you like do a number crunching, just stay away from this question. So that brings us to the end of part 1, where we discussed measurements and some engineering mathematics statistics. There is a lot of intersection between the two. So there is this SIO and systematic errors and random errors in measurement, expression of uncertainty and all that. Okay. The propagation of errors. So far, there has been only one question. That too in PM 2024. Okay. So that is something that is not covered in this set of PYQs. Perhaps when there are like 4 more years of question paper, that is something that we'll see in the future. But right now, there aren't a lot of questions there to discuss it. What we can do is we can come back and discuss the measurement devices. Okay. And we'll do control separately. So quickly recap. This is very powerful. This is very useful. Eliminate, verify, rules of thumb for NAT questions and all that. All right. There is typically a question from this every year. You can easily answer that. Okay. Mean, median, mode, accuracy, precision. Even that most of you could answer. Right. Know the differences. There were 2 miscellaneous questions in my opinion. In fact, or 1 miscellaneous question. Either this, okay, this is almost expected every year. Summation of 2 normal variables. Again, it's a normal. The means and variances add up. A question from that is expected every year. Or area under the Gaussian curve. Within 1 standard deviation, it's 68%. Within 2 standard deviation, it's 95.5%. 3 standard deviation, I think 99.7%. There is a question based on this. Okay. This question was miscellaneous, combined standard deviation, but I kind of explained to you, it's just weighted average. And this is also weighted average, but you have to account for discrepancies in the combined data. This accounts for discrepancies in the account data. Okay, in data. So if you do that, you could get it. But this is a question, this is a formula I would not necessarily remember. If you can easily write it down the way I did, that is fine. Else, even I would skip this. This is very time consuming, very well known. Okay. These questions are very time consuming. Based on the time left, decide how you want to deal with it. Okay. In fact, this was rather a demonstration of how time consuming it is. This is what you're going to do in the actual examination. Okay. You are constrained to a get calculator, mouse clicking and all that. So be careful how you deal with this. Okay. If I were you, I would just guess and move on. Okay. As I initially guessed 86, I would just guess that and move on. Instead of spending 10 minutes, 15 minutes, getting an incorrect answer, 90, just guess 86 and move on. Regression coefficient, at least you can easily find out. Okay. Okay. So that is the end of it. I hope end of part 1. We'll meet again for part 2.